Now, researchers have found the brightest burst of light ever recorded.
Since late last year, now the James Webb Telescope has reached its hovering orbit.
The James Webb Telescope recently made a groundbreaking discovery: strange, glowing lights emanating from Proxima Centauri B, a planet located an astonishing 7 trillion kilometers away. These mysterious illuminations bear a striking resemblance to city lights on Earth, raising the question: could they be signals from extraterrestrial life? What if humanity's greatest discovery is just within reach? As our state-of-the-art observatory delves deeper into the enigmas of Proxima Centauri B, prepare to be amazed. While scanning the vastness of space, the telescope detected these unusual lights on a distant exoplanet orbiting a star beyond our solar system, uncovering secrets that could change our understanding of the universe. The lights have a similarity to what we see when we look at cities at night on Earth, which raises the exciting possibility that there may be an extraterrestrial metropolis on this far-off planet. Scientists are ecstatic about this prospect because it may be the breakthrough they have been waiting for. It raises the question of whether sentient creatures exist and if the earliest indications of their existence may already be in front of us. They may even be existing in ways that we haven't yet considered. A scientist observed that lights were flickering at strange times as the data came in. Did it seem random or like a message? The team debated intensely, each new idea sparking fresh questions. Meanwhile, concerns grew. Could technical difficulties put the investigation at risk? Around the world, people watched eagerly, wondering if we were on the verge of discovering that we are not alone in the universe. NASA scientists were astonished that these mysterious lights could be detected from such an immense distance. They couldn't help but question how long these lights had been shining unnoticed, only now revealed by advancements in our technology. Columbia University astronomer David Kipping studied the planet's complexities, driven by its unique relationship with its star, Proxima Centauri. Unlike typical rocky planets that absorb sunlight and radiate heat, Proxima Centauri B appeared to behave differently. However, the true intrigue lay beyond the mere detection of lights in space. This discovery hinted at something far more profound. It also demonstrates how crucial the James Webb Space Telescope is to our understanding of the cosmos. It not only raises the prospect of life beyond Earth, but also challenges us to consider what life may be like elsewhere in the universe. Is it possible that societies exist that operate entirely differently from one another? The telescope's exceptional ability to capture infrared light was crucial in identifying Proxima B's distinct heat patterns. This discovery is significant since it advances our knowledge of the planet's atmosphere. Currently, scientists intend to utilize it even more to probe the planet's atmosphere and determine whether life may exist there. It is particularly well known for its capacity to identify infrared light, which makes it an excellent tool for studying Proxima Centauri B at night. This telescope is capable of detecting even the faintest glimmers in space, unlike others that struggle with dim light. This makes it the perfect tool for determining whether artificial light exists on the planet's dark side. Designed to identify artificial lights in space, the telescope operates within a highly specific frequency range, much narrower than that of natural starlight. The planet's relationship with its star is particularly fascinating. Its solar panels can absorb large amounts of energy while facing the star, and scientists are also interested in the light reflected off these panels. Similar to Earth, the planet experiences day and night cycles as it orbits its star. However, the contrast is extreme, with scorching days and frigid nights. The most challenging aspect, though, is the possible absence of an atmosphere, which could explain the drastic temperature variations. After a sweltering day, the temperature drops significantly because there is nothing to trap heat throughout the night in the absence of an atmosphere. Astronomers are interested in these extreme temperature fluctuations because they may provide information about whether or not it has an atmosphere. The telescope's cutting-edge infrared imaging makes it ideal for examining the planet's heat and providing important information about its atmosphere. The fact that the telescope's orbit precisely aligns with its own orbit makes it much more remarkable. This implies that it will be able to observe the day-night cycle of the planet up close once every 11 plus 2 Earth days. The next step would be to analyze its contents to determine whether it could sustain life. The presence of an atmosphere containing methane, oxygen, and water vapor would be strong indicators of potential life in that region. Discovering these elements would strongly suggest that the conditions might be suitable for life. However, gathering and analyzing light from the planet's atmosphere is a complex task. While its primary function is to measure components like water vapor, carbon dioxide, and methane, it is equipped to handle the challenge. Nevertheless, this data is crucial for understanding the planet's environment. It is having trouble locating bonded oxygen, a crucial indication in the hunt for life. It is still hard at work scouring the skies. It does, however, monitor other significant components closely, such as ozone, which provides valuable information on how robust an atmosphere a planet may have. Scientists are becoming more and more excited about learning the mysteries of distant planets as they examine the data from this telescope. We are getting closer to the answer to one of the greatest mysteries of all with each new piece of knowledge. Is Earth the only location in the cosmos where life exists? It is limited to observing a small number of reasonably nearby planets at this time. To explore these distant planets in greater detail, attention is shifting toward advanced instruments like the Extremely Large Telescope, ELT, set to begin operations in 2028. This cutting-edge telescope will offer a much more detailed view, helping scientists assess whether these planets could potentially support life. The data it provides is transforming our understanding of the universe. While its contributions are already remarkable, the insights we gain today will not only reshape our view of the cosmos, but also influence the future of space exploration. Future space telescopes are expected to block out the intense light from distant stars, much like we shield our eyes from the sun with our hands to see more clearly. This will make it easier for scientists to see the faint planet reflections and investigate the atmospheres to determine whether or not they could be home to life. It is difficult to distinguish between gases originating from natural processes like volcanic eruptions and life forms in the atmosphere of a planet. Now that these fascinating results have set the stage, we can focus on how these findings will influence our future exploration of the cosmic unknown. James Webb's contribution to the search for extraterrestrial life is significant. Scientists are putting a lot of effort into enhancing their techniques for distinguishing between these signals, which will facilitate the search for actual signs of life. But discovering life is not the only goal of this quest. It also aims to discover more about these far-off worlds. Thanks to the James Webb Space Telescope, we are getting an early glimpse of what future space explorations might uncover. Each discovery deepens our understanding of the universe and challenges our existing knowledge. The question of whether we are alone in the cosmos has persisted throughout human history. Now, this telescope is being used to scan different regions of the sky for signs of extraterrestrial life. As the idea of life beyond Earth gains traction, scientists are working diligently to find proof. In 1984, American astronomers Jill Tarter and Thomas Pearson initiated the Search for Extraterrestrial Intelligence, SETI. They founded a nonprofit organization dedicated to using the 42 dishes of the Allen Telescope Array, situated in California's foothills, to detect potential radio signals from space. These signals are an important tool in the hunt for life because they can travel over long distances with little interference. SETI has been listening for signals from extraterrestrial civilizations for more than 30 years, but they haven't heard anything distinct. However, Jill Tarter doesn't give up hope. She thinks that we are closer than ever to making a significant discovery, thanks to today's cutting-edge technology. Tarter envisions this endeavor growing into an international undertaking that unites people around the common objective of discovering extraterrestrial life. The scientific community recently became very excited about a new NASA report. It suggested that something as amazing as city lights on a distant planet could have been captured by this telescope. Situated 1 million miles away from Earth, it allows us to investigate the secrets of the cosmos in a way that has never been possible before. providing hitherto unattainable information. Despite these challenges, the planet receives sufficient light to maintain surface temperatures necessary for life. This warmth could allow liquid water to exist in oceans. However, due to its proximity to the star, the planet is tidally locked, meaning one side constantly faces the sun while the other is shrouded in darkness, resulting in two vastly different environments. This is similar to how the Moon always shows the same face to Earth. Despite its small size, Proxima Centauri produces enough energy to potentially support life, perhaps even in forms similar to those on Earth. But the question remains, is there any concrete evidence of extraterrestrial civilizations detected by the James Webb Space Telescope, or are we simply seeing what we hope to find?